Assalamualaikum and good day, esteemed judge, committee members, and fellow presenters at InnoTech 2026. My name is Aisyah Binti Anuar, and today I want to challenge the very way we think about electricity, sustainability, and power. My presentation is titled Energy Harvesting, Innovating Everyday Object to Power the Future. Think about our relationship with modern electronics. We live in an era where we are constantly chained to wall outlets, carrying tangled of charging cable, and worrying about battery percentage. But what if the solution to our energy need isn't about building bigger power plants or finding more things to burn? What if the power we need is already all around us, hidden in plain sight, waiting to be captured? Over the next few minutes, we will look at how cutting-edge material science is transforming passive everyday object into active autonomous power generation. To understand why this innovation is so critical, we have to look at the immense burden of centralized power and battery dependency. Right now, in 2026, there are billions of active, connected smart devices on the planet, ranging from the smartphone in your pocket to industrial sensors in factories and environmental tracker in the wild. Every single one of these devices requires electricity. These have triggered a quiet but devastating global battery crisis. We rely heavily on chemical lithium-ion batteries. Manufacturing them requires aggressive mining for finite resources, and when they degrade, they create millions of tons of highly toxic electronic e-waste that pollute our soil and water system. But here is the irony. While we worry about battery life, billions of gigajoules of fuel as usable energy are being completely wasted around us every single second. Every time someone steps on a pavement, every time an engine goes ahead, and every single second a Wi-Fi signal transmits through the air, energy is released into the environment and lost forever. The problem isn't a lack of energy, it's our absolute dependency on central grid, and chemical storage. The true innovation is shifting our mindset from power consumption to ambient power harvesting.
What exactly is micro energy harvesting? In simple terms, it is the process of capturing minute amount of ambient energy from the surrounding environment and instantly converting it into usable clean electricity right on the spot. Instead of generating megawatts of electricity at a distant coal or nuclear plant and sending it through miles of cable, we are harvesting microwatts or milliwatts of localized power precisely where the device is being used. We do this by tapping into three primary ambient sources. First is kinetic energy, which includes mechanical vibration, human movement, and physical pressure. Second is thermal energy, which takes advantage of waste heat from industrial pipe, car houses, or even the natural warmth of human skin. And third is electromagnetic energy, which involves catching the stray, invisible radio frequency, and Wi-Fi waves that we constantly bouncing around our modern world. By capturing this ambient force, we can make more electronic components completely safe, such as pull back the curtain of the actual science. Why do we take something as simple as footstep or warm touch or invisible Wi-Fi wave and turn it into real, usable electricity? The magic is either moving gear or burning fuel. It is entirely hidden inside advanced material science. We are utilizing three distinct families of innovative materials to capture this ambient energy. First, let's look at piezoelectric crystal. The word piezo comes from the Greek word for pressure. These crystals have a unique, highly organized atomic structure. In normal state, their positive and negative charge are perfectly balanced. But the moment you apply physical pressure, when you step on them, bend on them, or cause them to vibrate, you basically deform the crystal lattice. This mechanical stretch causes the positive and negative ions to separate, creating an electrical imbalance. That imbalance creates a bottom. It is a direct, instantaneous conversion of mechanical force into an electric current. Next, we have thermoelectric model, which operate on a fascinating principle known as the seatbelt effect. Imagine a tiny semiconductor chip made of two different materials sandwiched together. When we place on one side of this chip against a heat source like a hot industrial pipe or warm human skin and keep the another side exposed to cooler ambient air, something amazing happens. The electron on the hot side get excited and start moving rapidly toward the cold side, seeking equilibrium. This continuous flow of electrons from hot to cold creates a steady, predictable electrical current. As long as there is a temperature difference, you have a solid-state battery that never dies. Finally, we have RF harvester. Our air right now is absolutely saturate with stray electromagnetic wave from RT towers, Bluetooth device, and Wi-Fi router. These harvesters use microscopic, highly optimized antennas called red antenna. They intercept this higher frequency, alternating current wave of their travel through the air and instantly convert or rectify them into direct current electricity. This material acts as the invisible, silent machinery of the future, turning the idle background noise of our universe into digital. To appreciate why this is a massive paradigm shift in innovation, let's look at the head-to-head comparison model on the screen. It is vital to clarify a common misconception. Micro-energy harvesting is not trying to replace massive green energy like solar farm or wind turbine. Instead, it solves a completely different, highly localized problem. Let's look at scale and infrastructure. Micro-renewables require massive solar field, concrete wind turbine foundation, and heavy copper grids to move electricity across country. They are incredibly capital intensive. Micro-energy harvesting requires zero dedicated land. It is because it features invisible integration. It takes the concrete, the clothing, and the infrastructure we all have and simply upgrade the material to be self-generating. Next, let's look at location and efficiency. Traditional energy is centralized and remote. When a wind turbine in a desert generates electricity, a significant percentage of that power is lost as heat just traveling through hundreds of miles of transmission line to reach a city. Microenergy harvesting completely eliminates grid loss because it is instantly localized. The power is generated right at the exact millimeter where the consumer device is sitting. Finally, consider the purpose. Micro-renewables are designed for micro-consumption, keeping heavy power grid, entire city, and manufacturing plant running, while micro-harvesting is designed to liberate our ecosystem of smart devices. By targeting the Internet of Things, medical implant, and localized sensor, micro-harvesting cuts the cost permanently. It takes the pressure off the central grid by allowing small devices to take care of themselves. It moves us away from a society that constantly drains external power and move us toward an ecosystem that sustains itself. Move out of the lab and look at how this innovation is transforming renewable infrastructure in 2026 through two incredible case studies. First, let's look at smart pavement. Imagine a crowd train station, a major airport, or a bustling city walkway. Thousands of people walk across this floor every day. By integrating visual electric tie beneath the floor surface, city planners are turning the simple act of walking into a clean power plant. Every single footstep compress the tie beneath it, generating a burst of electricity. In several pilot smart cities, these high-traffic pavements now completely power their own automated ticket turnstile, digital information kiosks, and overhead LED street lights that pedestrians are literally keeping the light on just by walking to work. Second, let's consider self-power wearable in healthcare. For decades, patients rely on internal pacemaker had to undergo invasive surgeries every few years just to replace a giant chemical battery. Today, using micro-thermoelectric and kinetic harvester, medical device can be powered independently by the patient's own body heat and the continuous motion of their heart muscle. The device harvests energy from the very light it is protecting, creating a permanent, self-sustaining look that completely eliminates the risk of the battery failure and repetitive surgery. So the horizon here at Innovate 2026, the long-term impact of this user-centric innovation is profoundly game-changing. By embracing ambient energy harvesting, we can phase out billions of disposable lithium batteries used in everyday commercial electronics, significantly reduce cost to waste. Furthermore, this technology gives us the gift of uninterrupted operation. Think about infrastructure monitoring, such as sensors buried deep inside concrete bricks to check for structural cracks, or wildfire sensors deployed in dense forests. Sending human out into dangerous terrain to change thousands of little AA batteries every year is expensive and in invention. Energy harvesting sensors never need to be plugged in, maintained, or turned off. They run continuously for decades. This aligns perfectly with the core mission of our conference, creating an impactful change for the world. True innovation is about extracting more from our planet. It's about mastering efficiency. It is about taking the energy we are already spending and weaving seamlessly into the fabric. Conclude, the future of power is locked inside a distant utility plant. It is right under our feet. It is in the warmth of our hand, and it is floating invisibly through the air around us. When we innovate to turn ordinary objects into self-powered guardians, we move one massive step closer to a truly sustainable, intelligent, and clean world. Thank you so much for your time and your attention today. I wish you all incredibly inspiring experience here at Innotek 2026. Thank you.